Hi guys, how you going? Today we're going to be looking at exponentials and logs. Okay, so what we want to do is find the relationship between logs and exponentials. Now, last year you did log base power 10. That works quite well for things like the pH scale and so on. Now, most things in life actually have this special number e. Okay, and we talked about that in the first video, what e was. Now, ln is in fact the log base power e, rather than writing it as log base power of 10. So therefore, basically ln and e are really inverses of each other. So if you're looking at this thing over here, e to the x equals a, then basically if we take the ln of both sides, we'll get x equals ln of a. Alright, so if you obviously have ln of a and put that to the power of e, that will get back to a. So you can flip it around whichever way that you want to do that. The laws that we use for logs are the same as what we used last year. Okay, so in terms of if we were looking at using ln of ab, then it simply becomes ln of a plus ln of b. Right? If ln of a divided by b equals ln of a take ln of b, and then this is a way of solving for a power. Remembering logs is simply something that we generally use to solve powers. Alright, so this sort of chapter we're going to be looking at is exercise 5b, and so therefore we're going to use some of these laws to do that. I'm just going to do one of these for you. I might do C. Alright, so if we start doing number 1c, alright, so if we're looking at that, we've got S equals a squared e to the minus kt. So what I want to use is my natural log laws to find that. So what I'll generally do is I take the ln of both sides. So ln of s equals ln of a squared e to the minus kt. Now the laws basically allow you to break this into different things, doesn't it? So I could say that's equal to ln of a squared, right, plus ln of e to the minus kt, and that's what my ln of s is equal to. So if I go down to the next line here, I could simplify ln of s equals, now I could use the power law and write that as 2 ln a. Now we know that ln of e to whatever cancels each other out, doesn't it? So therefore we can just say that's plus minus kt, so that's just minus kt, and that is written in log laws. Alright, so so that's number 1c. I'll probably show you the other way of going back the other way, so we might do, oh, I've got room here, I'll do it over here, so we'll do that in another colour for you. So let's do 2, we'll do 2c, alright, keep the c's going. So we've got ln of p, and that's equal to ln of g take 2t. Now keep in mind, we're now going to simply solve things by combining ln's. Now if you've got minus 2t, you could, if you wanted to, you could write that as ln of p equals ln of g take ln of, now ln of e to the minus 2t. Right, so you can actually write that in there. Because we've now got ln's like that, we can say that ln of p equals ln of, now the thing when you're taking, you're dividing, so it's g over minus 2t, isn't it? Oh, it's e to the minus 2t. So therefore what we could say over here, if you're going back to your rule, is that if you take those both to the power of e, that p is equal to, p is simply equal to g all over e to the minus 2t. So that's my rule that I've got there. Alright, so that's exercise 1 and 2 that you need to look at. Obviously, these are really crucial things to actually understand what's going on. So without using your calculator, evaluate that. Well, we know that these things are simply cancelling each other out. So if I've got e to the ln, ln of e to the 2, then that answer is simply 2. Right? If I had something like this one over here, number f, that's going to be e to the ln of 3 squared. So that's going to be 3 squared, which is 9. Right? Remember using a power rule. So these are the same rules that we were using last year when we were using logs. Just a little tricky one here. If I was doing, say, h, that's going to be equal to e to the ln of 2 to the minus 2. So we know that 2 to the minus 2 is equal to 1 over 4. Alright, so you need to have a bit of practice at doing these. So simplify ln of k using the log laws. Alright, so let's do b again. So b, so 4b. So if we were looking at that, we've got 3 ln of 4, take 2 ln of 2. So that's going to be equal to ln of 4 to the power of 3, take ln of 2 to the power of 2. So therefore, what's 4 to the power of 3? Well, that's going to be 4 times 4 times 4 is 64. So that's ln of 64. Remember, when we're taking, we have to divide. So that's all over 4. So that's equal to ln of, I think 4 goes into there how many times? 16, doesn't it? Is that right? Yep. So that's ln of 16. Okay, which was simplified. So we simplified that into the form of ln of k. So that's the other one. When we're doing something like number 5, then what we'd be looking at there is obviously writing it as a power of e, right? So you remember e and ln cancel each other out, so that would be, if we're looking at, say, number a, so 2 is equal to e to the ln of 2, right? Well, our ln's a bit dodgy, but you can see the idea that we've got e to the ln of 2 because we know that they cancel each other out. It's really important that you understand that. Okay, very quickly, I think my battery is going to run out, so I might just stop this video now and I'll do the next part in the next video.